All right, so in this lesson, we're going to go through and estimate a mean. We're going to do a confidence interval for means, whereas we were doing proportions prior. And so, first thing we're going to go through, and we've done it before in the previous chapter with checking conditions, doing the random again, and then also the normal or large sample condition. We're going to determine the critical values. Our critical values for this, since we're dealing with means, are going to be what's known as a t-star. T-star is what our critical value is, whereas proportions we're doing a z. And then we're going to go through and calculate a confidence interval for the population mean, is what we'll end up with. Checking conditions. Now, we've checked conditions with proportions. We're doing the same thing for means. We just have to remember we got to hit the random clause again. And then the normal and large count clause changes. Instead of doing the NP stuff, greater than or equal 10, we're going to compare it to 30. We can also, and this comes from the central limit theorem, the CLT that we learned last chapter, that if they tell us that it's approximately normally distributed, even if my sample size is below 30, I can go ahead and do it. Okay, so we had the central limit theorem said that if they tell us that it's approximately normal or my sample size is bigger than 30, then I can go ahead and treat it like a normal distribution and do the stuff, the confidence interval, and find the probability stuff. So we get to use both of those things as we're looking for normal large. So the first example here says a particular machine manufactures rubber gaskets with outside diameters that vary according to approximate normal distribution. To estimate the mean outside diameter of all gaskets produced by the machine during a production run, a quality control engineer randomly selects 10 gaskets, checked if the conditions for calculation. Can we do the confidence interval from you? So we're going through here checking random and then large count. So random, they said, randomly select 10 gaskets. So randomly selects 10 gaskets. So that's the first thing. We met that condition. Large count. Well, the first thing we look at, we say, well, n is 10, and that's less than 30. So we're thinking that we failed. However, they do tell us that it varies and accordingly, and it's an approximately normal distribution. They tell us that it's approximately a normal or normally distributed. So with that in mind, since they tell us that portion right there, we don't have to worry about the sample size being 10. This lets us know that, hey, we meet the conditions for large count. So we can go ahead and execute or calculate the confidence interval. So on the next one, real quickly, do we meet the two cases? Random and large count. All right, I heard a yes. So let's see. They said you did a random sample of 32. So random sample of 32. Now, with that in mind, n is equal to 32, and that's greater than 30, so we meet that clause, okay? So we could go ahead and do the so yes, we can calculate the confidence interval, okay? Let's skip ahead. Critical values are T-star, how to find them. We have two options, and I got to show you both because some of the questions in our homework tonight online require you to use Table B, is what they require to use, okay? So I want to show you. Now, I put out in your handouts folder, as soon as mine updates, there you go, Table B. I put this Table B thing out there for you, okay? Now, there's two ways to look at it. You can look at the top, Now the top line here, the 0.25s, this stuff right up here, if I can get to a tool that actually writes, those little thing there, that's what you get after you do like the 1 minus your confidence percentage divided by 2. So when you're looking at matching up, well, what column do I go to? The top row there of the 0.25s, and that's what you get after you do your 1 minus your confidence level divided by 2. So for the area, what is the area we were typing in for inverse norm? All right. Now, if you don't like that, if that's too much work for you, look at the very bottom. The very bottom actually tells us the confidence levels. So we don't have to worry about doing that other stuff. We don't have to worry about doing 1 minus 0.90 divided by 2, seeing that it's 0.05, and then going to the 0.05 column. We can just find the 90% column and then work our way and say, hey, we're only this stuff in this column. Okay, so that's what's nice about this one, is that it has the intervals at the confidence intervals at the bottom for the percentages. Okay, so which is nice. Now, here's the challenge. In class, I was starting to try to, when we were doing the Z-stars, and I would say, hey, is that one this? And I would, like a 95% confidence interval is like 1.95996, blah, 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 blah. A 90% confidence interval is a 1.644, and it goes from there. Well, when you're doing a Z interval, those numbers are easy to memorize. The challenge when you're doing a T interval, you can't, because it's all based on the sample size. Because when we're doing our T interval for means, the Z interval assumes you're 30 and above, and so you meet that condition. So hey, we're sweet. It's gonna, no matter what, it's gonna be the same. So here we learn about this little thing called DF. All right, the DF stands for the degrees of freedom. And so, well, how do you find the degrees of freedom? It's just your sample size minus 1. That's how you figure out what your DF is. Sample size, or n minus 1. Now, do you remember back in chapter 2 when we first learned how to do standard deviation, and sometimes the fat R was divided by n, and then if we did SX, it was dividing by n minus 1? That's the same thing here. We're going to take, since we have a sample size that is a little bit less, we're going to give ourselves a little bit of room, a wiggle, and do 1 minus that sample size just to make our interval just a little bit, not super, strict. It's going to give us a little play, okay? What we basically would do is, as we do a problem here, if they want to say, okay, what's a T star? What is a T star for a confidence interval or confidence level, a C level of 90%, and my N is equal to 18. Let's say 18. So what we would do is I'd first go to the 90% column, which happens to be that column right there as I arrow it on the screen here on my stuff. And then now I would say, all right, if my sample size is 18, my degrees of freedom would be 18 minus 1, which is 17. So now I go up to the 17th row, and I come and I go to the right until I get to that column. And I say, all right, my T star for this situation is 1.740. It looks like what my eyeballs see. Yeah. So there's what my T star is. The online homework, it'll say don't round. And it tells you to use table B. That's what you're going to have to do. You just grab the number off there. All the decimals on here are to the third decimal place. So it's like, hey, just write this thing down in the cell. Now I'm going to show you another way to do it on the calculator. That one's going to give us more decimals because it's more accurate. There is a formula to figure out these T stars are critical values for T, and it's a very long formula. Okay? And so the calculator does it by that formula because it's like more precise. So with that in mind, hold on a second. I just had a little, what was I going to say? I just lost my train of thought. Oh, do it in the calculator. In the calculator, we're going to look for an inverse T. So on your calculator, as I go on the middle screen and on the top screen is where I left and right screens, get my TI calculator up. If you do a second vars, you'll notice option number 4 says inverse T. Go ahead down to that one. Choop. And I'm going to hit enter. And now this one tells me to do my areas and degrees of freedom. So again, I forgot that's what this one likes. It doesn't do vertical. So with that in mind, my area. So for this problem, it was 1 minus 90% divided by 2, which is 10% divided by 2, which is 5%. So my area is 0.05. Oopsies, that's 50%. 0.05. And then comma. And then we would type degrees of freedom. We would type in 17 and hit enter. And notice how it gives us a little bit more out there. Our calculator says 1.739606668. So when you do this for homework tonight and you choose to use the calculator, this inverse T, you got to round it to the third decimal. So this would give me 1.740 because the 6 makes the 9 go to 10. And that's now that now matches what's on the table. And so that's what you're going to have to do on your homework tonight for these kind of problems for T-star. If you choose to use the inverse T thing, you're going to have to round it to the third decimal is what you're going to have to round to. Okay? Now, here's the other part you got to be careful. Let's scroll over and look at I'm going to get rid of the calculator. Let's scroll over and look at the way the chart goes. Notice that they have all the numbers from basically 1 all the way down to 30. And then they start saying 40, 50, 60, 80, 100, 1,000, and then infinity. So what that means is if they say, let's say I have a sample, let's say my n was equal to 39. That would mean my degrees of freedom would be 38. Yes, 38 is close to 40, but I actually have to use 30 as my degrees of freedom if I was doing this by hand and saying that my T-star is something in this row right here. If I do something like 79, 79 means I have to go down to 60 and use that T-star. If I had 999 was my degrees of freedom, I'd have to go down to 100 and use that T-star. So be careful when you look at your problems tonight. I don't know if they have any huge samples bigger than that. And if they want you to use table B, then you're going to have to use table B. Because if we go in and let's do that n is 30, let's do the degrees of freedom as 38, and then let's just compare it to, let's use that as our area, the 0.25. Let's use that as our area. So if I go back in and do an inverse norm, or inverse T, second inverse T, and then my area is 0.25, comma, we said 38 degrees of freedom, and hit enter. And then now, when I go to look at the comparison, on the paper it says 0.683. On the calculator it says 0.681. That thing being off by 0.002 can affect things as we use it for other calculations. Okay, so make sure if they ask you to do a T-star based on a big sample size, use the paper. If it's something bigger than 30. Okay, and so remember that's in your handout folder is where that's out. All right, let's get back to what we're doing. So now we're going to go through and do this stuff off the other way. So notes, nope, there you go, there's notes. And bring that back over. All right. So that's the explanation right here for how to find T-star. I would suggest using inverse T when you're giving the freedom. Makes it a lot easier. You just got to type in the area, which is that same 1 minus your C percentage divided by 2. And then your degrees of freedom is your N minus 1. Okay? And then let it do the work for you. So that's what they wanted you to practice here. They tell you to do it from table B here. Do you need to practice that at all? We did it a couple times. You guys okay with using that inverse T? All right, so let's scooch ahead. I have some more practice ones there that we can throw down the answers on there. Again, they tell you from table B is where they want it. Again, you can use the calculator. Just round it to the third decimal is all you got to use on that part. How do we calculate a confidence interval from U? Well, here is what it's based off of. It's X bar is our point estimate, plus or minus the T star, and then the sample deviation divided by the square root of N. All right. So it's, we'll do one by hand, then I'll show you the calculator method on it next. So in this problem here, the gasket problem here, remember we said conditions were met. We had a random sample of 10. It did said it was normally distributed or followed that pattern, so we said we met that clause for large count. So with that in mind, I want to construct a confidence interval, which I know the formula is X bar plus or minus T star times the sample deviation divided by the square root of N. Okay. So as I pull information out of here, X bar, they told us, was 41.79. Plus or minus, we got to get some T star. I'm going to grab it from the paper here in a second. Or actually, I'll do an inverse T and round it to 3 decimals. My standard deviation is 20.21. And then my square root of my sample size, which we said was 10. Okay, remember N was 10 for that earlier problem. All right, so I need my T star to go in that little part right there. So on the calculator, we're doing a 95% confidence interval. So that means I'm doing an inverse T. My area is 0.025. My degrees of freedom is 9. Again, I did an inverse T. My area was 0.025. My degrees of freedom was 9. It gave me 2.262, 157. 2.262157. That'll get us close enough to what the calculator will give us in a minute when we do it faster. So now we just get to start doing that math. So what is alpha y equals? Give me a fraction. 0.21 divided by the square root of 10. And I'm going to multiply. Again, that is 0.0664078 times that decimal there, plus or minus the 41.79. So times 2.262157. So it's 4179 plus or minus 0.15022249. So I'm going to add 41.79 to that, and that gives me that my upper bound is 41.9402. And then I'm going to do 41.79 minus that other decimal. And that tells me my lower bound is 41.6398. And again, since I took my decimals out long enough by hand, when we do it by the faster method in the calculator, we're going to get about the same answer. I'm going to split screen while you guys are copying this down and get my calculator back up there. Now, how can we do this faster? I showed you how to do it faster doing the one prop Z interval. What we're going to do here is we're going to do just a T interval. That's the feature in the calculator we're going to use here, a T interval. So I'm going to hit stats, go over to test. It's option number 8 is a T interval. Now, it has two options here. It has data and it has statistics. If they don't tell you X bar and they don't tell you XX, but they actually give you a bunch of data, then type it into L1 and then we get to use that data feature. They gave us statistics. We know they gave us statistics because they gave us X bar. They said X bar was equal to something, 41.79. Whoops, 41.79. They told us that S sub X was 0.21. So I'm going to use that feature, arrow down, and say, all right, 41.79. 0.21 is my SX. Sample size, I don't have to do degrees of freedom here. I just type in my sample size of 10. Confidence interval for this problem, wasn't it a 95%? Yeah, 95%. So I'd go ahead and type in those things again. N is equal to 10, and my C level is 0.95. Go down to calculate and hit enter, and it gave me 41.6398, comma, 41.9402. Is that the same thing I got by hand? Looks pretty darn good to me. Okay, I got the same confidence interval. Again, if you take it out, your confidence interval, a certain number of decimal places in those other stages, like 6 or 7, then you're fine. You'll be accurate to what the calculator gives you. Again, I would suggest doing the rest of your confidence intervals for means using this T interval feature. That's what I would suggest. Okay? I know it's 21 after. Let's do one more. We're going to do it the fast way. Okay? We're going to do it the fast way with the calculator using that T interval. We're going to do a T interval. I need that one. We're going to do a T interval. And so with that in mind, let's go through the problem. Tootsie Pops. He instructed a sample of 92 students so that's my N. N is equal to 92. Had them lick a Tootsie Pop to see how long it would get to the center of the Tootsie Pop. The mean number, so X bar, is equal to 356.1. Standard deviation, so that's SX, is equal to 185.7 licks. And my C level is 95%, so 0.95. So that's all I need to pull out. I'm ready to go ahead and do my confidence interval. Those are the things I'm going to type in. So stat over to test, option 8. We got data, we got statistics again. So with that in mind, wrong button. There we go. My X bar was 356.1. There's no decimal point in there. 0.1. And then my SX was 185.7. My sample size was 92. And same confidence level. Fantastic. Enter through. And this tells me that it's from 317.6426 up to 394.5574. So there's my confidence interval. Okay. Again, calculator features make it go a heck of a lot faster. Okay. We got the foundation then there because that way you can answer some of those easy ones that I did on last test. It said what was the correct format for the normal CDF, for the problem as they worked it. They want to know what were you typing in as your calculator command. So I'll do the same thing on this one. I'll have some ones that, hey, what's the right setup? And I'll give you a multiple choice. What's the right setup for the way the confidence interval is calculated with the X bar plus or minus, or maybe it's P hat plus or minus, whatever. Okay? We are using, when we're doing proportions, we do Z. When we're doing means, we do T. There is a T. I don't know if you notice that there's a Z for the intervals. Notice how there's a Z test. There's a Z interval. Okay, our book and our homework assignments and stuff are based off of doing the means for T, proportions for Z. Okay, you actually can use the Z interval stuff for means as long as n's bigger than 30. But since all of our stuff based off the way it grades on the online assignments, in order to do a means, it's got to be done with T. That way you get those problems right, okay? So, and the same thing will be my test when we take a test on this on Friday, okay?